Lower bound and upper bound of a decimal. Let me quickly give you the idea. Let's say a number is rounded to one decimal place and we have 3.5. The number is rounded to one decimal place. What we have is 3.5. This 3.5 is not the exact value. It is only an approximation. The real value lies within limits, and these limits are called lower bound and upper bound. Since the real value lies within lower bound and upper bound, how do we find lower bound and upper bound? The first thing you need to know is what the number is rounded to. Here is rounded to one decimal place. Rounding unit for one decimal place is 0.1. We take the half of 0.1. How do we take half of 0.1? We divide by 2. We have 0.05. With this, we can find the lower bound and upper bound. For lower bound, what we need to do is to subtract 0.05 from the rounded value minus 0.05. We have 3.45. We have found the lower bound. Now, to the upper bound, we had 0.05 to the 3.5 plus 0.05. We have 3.55. We have found the upper bound. If we bring the lower bound and the upper bound together, what we have will be range of values. Look at the way it is. It will be lower bound less than or equal to the real value. The real value less than upper bound. Permit me to write it like this because of space. What is our lower bound? Our lower bound is 3.45. 3.45 less than or equal to the real value. The real value less than 3.55. I want you to notice something. Here we are having less than or equal to the real value. The real value less than, just less than. You discover that the lower bound is inclusive. That is why we are having less than or equal to. But the upper bound is not inclusive. Why? If we put less than or equal to, the real value can change to be another value. That is why the upper bound is not inclusive, but the lower bound is inclusive. Like this, we have learned how to find lower bound and upper bound of a decimal. In my next video, I'll be dealing with two examples. Watch out for it.